Hey there, welcome back to another episode of Tech Break by Friday. Today, we have another episode of the series AI Demystified. Our topic today: what is the real difference between artificial intelligence, machine learning, and reinforcement learning? Spoiler, they are not all the same, and understanding the difference will help you spot the hype for the real deal. From our last episode, let's remember what AI means. AI is an algorithm that recognizes patterns based on data that has already been seen. The period that AI learns from data is called training period. After training, AI is capable of recognizing the patterns in the data. An example that you might already have seen is the Netflix recommendation system. Based on the movies you have seen, it proposes new films and series that you might like. So, let's answer the question: what is machine learning? Machine learning is a part of artificial intelligence that allows computers to learn patterns from data and make decisions without being explicitly programmed for each task. Unlike traditional software, which follows instructions if A then B or else C, which A, B, and C are specific tasks or conditions, we have another widely cited definition by Tom Mitchell that states a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if the performance at tasks as measured by P performance improves with experience E. For example, because this sounds a bit complicated, an email spam filter is a machine learning solution. The spam email filter is a task, T. The machine learning algorithm gets better at recognizing spam emails. This is the performance P measurement. And basically, performance means how many emails have been recognized correctly as spam or not spam. The data that has already been seen or processed, which in our case is labeled emails of spam and not spam, are the experience. So, for example, in the training period, there would be some examples of spam emails that will be categorized and labeled as spam, and some non-spam emails that have been categorized as non-spam. So, let's see what are the core types of machine learning. First of all, we have supervised learning. In supervised learning, models are trained using labeled data. Each input has a known output. This means that the algorithm learns to map inputs to outputs by minimizing the prediction errors. Typical applications include classification, sorting email as spam or not spam, or other like labeled tasks, for example, sick or non-sick individuals, something like this. Regression, which means predicting house prices based on features like size and location. Difference here is that the data are not countable like spam or not spam. What this means, for example, the house price range is not countable because it can be like from like $10,000 to like 500,000 to like a million to 10 million. So this range can vary based on the size of the house, the location of the house, bedroom, bathroom size, and many other things. For example, in New York, it's based on location, it's based on amenities, and different other things. So basically, the idea is that regression is able to predict a huge amount of range, and classification is more about something that is countable, that can be basically distinguished into categories like 1, 2, 3, 4, 5 categories, and then basically the algorithm can map the inputs to these specific outputs. The model uses its training to make predictions on new and unseen data at the end. So, in unsupervised learning, we have the feature that it deals with unlabeled data. What this means is that we don't know exactly what the data are before we have actually tried to learn from them. The algorithm tries to find hidden patterns or groupings within the data. Standard techniques include clustering, grouping similar customers, for example, and this approach is often used for anomaly detection. For example, you're given different shapes of objects manufactured, let's say. The unsupervised learning method explores all possible options to recognize which of these objects were created with anomalies, let's say, and it tries to recognize the anomalies based on the other objects that have been manufactured from different shapes, and it thinks that they are normal. So basically it clusters, okay, which are similar and they look some sort of the same and they are normal, and which of them seem to be with some sort of differences, which could be anomalies. We also have reinforcement learning, which is about learning by doing. An agent interacts with the environment, making decisions and receiving feedback in the form of rewards or penalties. Over time, the agent learns which actions yield the best outcomes. Reinforcement learning is used in robotics, game playing AI like AlphaGo, and industrial automation where trial and error can optimize performance. Think about a video game where you can start with no instructions, just a controller and a goal to survive or score points. Every time your character jumps over a pit and survives, you earn points. So that's great. So now, let's say that you walk into a trap, you lose a life. Not so great. But you learn what actions help you win, jump at the right moment, avoid certain areas, and grab bonus items. That's reinforcement learning. The game is the environment, you are the agent, points and penalties are your feedback, your rewards basically. In real life, this is how AIs like AlphaGo learn to master complex games, or how robots learn to walk by trying, failing, and gradually improving with each attempt. Does this remind you a bit of like a human? Comment down below. If you found it helpful and you like this episode, share it with a friend. It helps more people find the podcast and learn about AI. Subscribe, leave a review, and keep building. Thank you very much.